There you are.
What happens is that a random element
a very specific meaning here. It means that among all of the things that are currently in the random queue, one of them gets chosen, each one is equally likely to be chosen. So random is not the same thing as arbitrary or convenient. It really means each one is equally likely to be chosen. So if you do the same set of operations more than once with the random cube, like you add a bunch of stuff, maybe the numbers 1 through n, and then you remove n times, well, the first time you do it, you'll probably get a different ordering of the elements coming out than the second time you do it. In fact, if you want a random permutation of 1 through n, put them all in there, and then remove them all, you'll get a uniformly random permutation. So that's what a random queue is supposed to do. And currently, the implementation does that. And the way it does it is it puts the elements in an array list. So when you add, it just appends it to the end of the list. That's fast, right? Adding something to the end of an array list, that only takes constant time. And when you remove, well, it takes a random index I between 0 and the number of elements minus 1, and then removes that ith element from the array list. Okay, so this indeed does give you a random element, right? From all the stuff that's in there, we take a random index, and so we get a random element. What's the problem with this implementation? Yeah. Yeah. So the remove operation takes a random element, and so it's equally likely to be at the end, at the front, or in the middle, or anywhere else. So somehow, on average, you're removing from the middle. And you can formalize that by saying, on average, the expected value of the index that you take is about n over 2, which means, well, on average, you have to shift n over 2 elements once you do this remove. So shift n over 2 elements. So the question says, fix this. Make it so that it's still random, but the remove operation goes a lot faster. I can't tell you anything more about that without answering the question. I think there's maybe a hint, or I'll give it to you now. The answer is basically 1 or 2 lines of code to answer this thing. Make it work fast. All right. The second question, you see it up there, is to implement something called a bulk array deck, which is just another kind of array deck. So remember, this array deck class is this thing that stores lists in an array. The list starts at position j in the array and continues at position j plus 1, j plus 2, and so on, so that it even wraps around the end of the array and goes all the way up to position j plus n minus 1, modulo length of the array. So that's this array deck class. And now I want you to implement a method called add all. It says, starting at position I in the list, add all the elements in some collection C. So C is another collection. It could be a list, it could be a set, it could be anything. Like C, you can use for loops to iterate over the elements in C. And add those at position I. So if we view it abstractly, we have a list. And someone says, okay, right in here, position I, put all the elements of this other collection C, them into the list starting here, so make the list grow out of that. So currently, there's a default implementation of this. The way the collection framework works is there's these things called abstract lists and I think abstract linked lists or something, but there is already an implementation of this. And the way that that implementation works, it's just inherited from this abstract class, is it just repeatedly inserts the elements of C into this thing. So it inserts the first element of C into position I, and the second element in position I plus 1, and the third element in position I plus 2, and so on. If you think about that for a while, that's not going to be terribly efficient. So what's the problem with that solution?